A fair coin, so that's a coin where the probability of getting a head is a half, and then the probability of getting a tail is also a half, is tossed 3 times. Let h be the random variable, the number of heads obtained. Find the probability function. So, if we look at a tree diagram, head, tail, then for the second toss, head, tail, and then for the third toss, we have head, tail on each of them, like so. So, we go to the top here, we'd get head, head, head as the outcome. This would be head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. The number of heads obtained would be 3, 2, 2, 1, 2, 1, 1, and 0. So the possible outcomes, the possible values, which we would call small h, of our random variable h are 0, 1, 2, and 3. Now, since all of these are a half, each of these outcomes has a probability of 1/8. So if we express this as a table, we would have the outcomes 0, 1, 2, and 3. These would be the possible values of h, and this would be the probability of h, which is shorthand from probability of the random variable h taking the value h. So for 0, it's just one of these outcomes, so 1 out of 8. For 1, we've got 1, 2, 3, so that's 3/8. Same is true for 2, 1, 2, 3, so that's 3/8. And then this one is 1/8. Something to note is that those probabilities all add up to 1, which you should know because it's absolutely certain that we are going to get one of these outcomes. There are, of course, other ways that you could have expressed this. So, for example, we might have decided that we were going to do it graphically. And so we would have the probability of h up here and the values of h along here. And then we would have 0, 1, 2, and 3. And then we might do this as 1/8, 2/8, which of course is a quarter, and 3/8. And then we know that this one is an 1/8, 3/8, 3/8, 1/8.